So here next point is analog signals. Okay, analog signals, analog signal. So here we have to classify the analog signal. So first, analog signal having two categories, that is simple analog signal and composite analog signal. Simple, okay, simple analog signal and composite, composite analog signal. Okay, so under the simple analog signal, uh, means दो टाइप से पहले एनालॉग सिग्नल्स में एनालॉग सिंपल एनालॉग सिग्नल एंड कंपोजिट, और सिंपल एनालॉग के अंडर two points are there, that is sine wave, okay, sine wave and sine wave and cosine wave, okay, cosine wave. And then under the composite analog signal, okay, इसके अंदर also having some parts. Let's see here. Okay, so in this having like square, okay, square, then you can say that array, complex shapes, triangular, this all our points are there. Okay, so let's see first analog signal here. So simple analog signal and composite analog signal. Let's see first the simple analog signal and composite analog signal. Okay, what is this? So here this simple and composite analog signal. Simple, okay, first is the simple. It is an analog signal which cannot be decomposed into simple signals. मतलब ये एक analog signal जो decompose नहीं होता simple signal में. Okay, so this is the most basic analog signal which can be used as basic building block to build other composite signal. Okay, it is so simple analog signal is a signal which cannot be decomposed into simple signal. So this is the most basic analog signal which can be used as a basic building block. Okay, this simple is a simple one, and this simple analog signal is mostly used for building block purpose. Okay, to build the other components composite signal means जो ये simple है ये किस वे के लिए यूज किया जाता है, to use as a basic building block to build other composite signal. Okay, अगर एग्जांपल लिया जाए सिंपल एनालॉग सिग्नल का, तो सिग्नल्स आर साइन एंड कोसाइन वेव. सो जैसे कि हमने कहा कि सिंपल एनालॉग सिग्नल, ओके, सो एग्जांपल आर signals are sine and cosine wave. Okay, so before I discuss about sine and cosine, let's discuss first composite also. So a composed analog signal is made of multiple sine और cosine waves. ये composite है, multiple sine और cosine waves से बनी है, of different amplitude add to the subtract from each other. So a composed analog signal is made up of multiple sine or cosine wave of different amplitude added to the subtract from each other. Example of composite analog signal are square wave, triangular wave, okay, pulse, and so on. So in sine wave means what about this simple analog signal? In sine wave, you can see this sine wave. It is the most basic type of, this is example of simple, okay, analog signal. So this sine wave, it is the most basic type of periodic analog signal. That means it is the simple analog signal. So here you can see this graph represent analog signal, right? So you can see a mathematical expression that is S of t equal to a sine in bracket 2 pi ft plus theta. Then peak amplitude, that is a. Frequency is nothing but f h z equal to 1 of t time, 1 upon time. Then period is equal to T equal to 1 of F, that is 1 upon frequency second. And phase is nothing but theta radians. So important point about frequency and time period. Okay, important point, let's see. Frequency and time period are reciprocal of each other. Okay, frequency can be defined as rate of change of magnitude with respect to time. Okay, frequency can be defined as, see, I'm writing like this. Okay, frequency can be defined as the rate of change of magnitude. Okay, rate of change of magnitude. Okay, so frequency can be defined as rate of change of magnitude with respect to time. Okay, with respect to time. So frequency and time period is reciprocal of each other. Frequency can be defined as the rate of change of magnitude with respect to time. Change of signal magnitude in short time span correspond of high frequency. Change of signal magnitude over a long time span correspond to low frequency. This signal which does not change at all has zero frequency. Example such a signal is DC, direct current signal. The signal that changes instantaneously has an infinite frequency. Example delta signal or impulse. So here you can see this phase, right? So phase shift theta equal to 0 degree. Expression is that zero phase shift. Okay, this is a phase shift. Let me express here. So here S, this is a S of t equal to a sine. Okay, S of t is equal to a sine in bracket 2. Let's go to symbol here. Okay, we require this area in this one. Just 1 minute. Mhm. So sine S of t equal to a sine 2 pi ft. Okay, 2 pi ft. So this is about the phase, which is the zero phase. Okay, so this is nothing but it is a zero phase shift. It's called zero phase shift. Okay, then 90 phase shift is having, instead of this, like this only. So यहाँ पे जो साइन वेव्स है उसमें आपको just first explain that this this diagram मतलब what is the frequency formula, mathematical expression. Suppose this like peak amplitude is nothing but a, then this periods and phase. Okay, radiance. So frequency can be defined rate of change of magnitude with respect to time. So यहाँ पे phases कुछ जैसे कि ये जीरो फेज है. ओके, अब 90 डिग्री फेज, दैट इज वन फेज. ओके, सो वन फेज का फॉर्मूला वी विल सी. ओके, कॉपी इट, हैविंग सम चेंजेस वी विल डू हियर. ओके, सो ये फेज आपको शो करना होगा. What happens? Okay, so यहाँ पे you have to write that 2ft plus 90 degree. Okay, so this is phase, one phase. Okay, or this is about one phase, and means you can say phase 9. Yeah, you can say this is zero phase and this is nothing but 90-degree phase, not one phase, it is 90-degree phase. Okay, 90-degree phase. Then here again copy it, and this is a 180-degree phase. So here you have to mention first 180-degree. So this is a three phase which you have to write in your sine wave. Okay, and then another after this, wavelength. So wavelength is another important characteristic of wavelength. Okay, this is also another important characteristic. Okay, so let's see. So here wavelength. Wavelength is another important characteristic of a signal traveling through a transmission medium. Wavelength rates the frequency of sine wave with the speed of propagation as follow. So here you have write wavelength like W I'm writing here, okay, is equal to propagation speed. Okay, propagation. Wavelength is indicated with the lambda also, okay, propagation. Okay, speed, propagation speed divided by frequency. Okay, so this is the formula of wavelength. So if you want to find the wavelength though, so wavelength is defined as a propagation speed into here. Wavelength is defined as a lambda. I'm writing a W. Okay, so propagation speed equal to upon frequency, then is equal to propagation speed. Okay, propagation speed into period. Okay, that is, you can say W or wavelength, a lambda equal to C upon F is equal to C into time. Okay, so this is about wavelength. Wavelength is another important characteristic of signal traveling through. Okay, transmission medium. So wavelength relates the frequency of sine waves with the speed of propagation as follow the formula of this. So wavelength of signal is depend on the medium. In data communication, the wavelength is used to describe the transmission of light in an optical fiber. So it's used to describe the transmission light in the optical fiber. Okay, so you can say that means we can say express that wavelength is the distance traveler by a single or an electromagnetic wave during the time period of one cycle of signal. Wavelength is a distance travel by signal or a electromagnetic wave during the time period of one cycle of signal. In vacuum of speed, light c is a 3 into 10 raised to 8 meter per second, but it does not remain same in a cable. Hence, the wavelength of the same signal will be in the air and on the cable. So, time and frequency domain, time and frequency domain. Okay, so time and frequency domain. So here it is possible to display a signal in either time domain or frequency domain. So it is possible to display signal in time and either frequency domain. Okay. So time domain display of analog signal. So this time domain display the analog signal. It is the length of graph of signal magnitude with respect to time. That means on the x-axis we plot the time t and the y-axis magnitude is period. Okay, so time domain display tell us about following like shape or time domain is display tell us that is shape of the signal, its frequency, then type of the signal, periodic or non-periodic. We have discussed about periodic and non-periodic in my previous lecture, right? One cycle period. So time domain is used to express the some points like shape of signal, means it discuss some with the help of this discuss the some points like shape of signal. Just for me. Okay. Mm, shape of signal. Okay. Shape of signal. Then its frequency. Okay. Then type of the signal. Okay. Then one cycle period. One cycle period. So this point is expressed via time with time domains, but we cannot know anything about what frequency component are present and in what propagation they have been mixed. In order to obtain the particular shape of all the signal, all the information can be obtained from the line spectrum of signal. The phase and frequency cannot be explicitly measured from the time domain flow. In case of composite waveform, which is composed of multiple sine wave of different amplitude, frequency and phase, the time domain plot does not reveal any information about the relationship between amplitude, frequency, and phase for the various sine wave. Okay, so okay, so here frequency domain and display or signal. Okay, so it is a graph of signal amplitude, peak or sometime, plotted on y-axis with respect to frequency plot on x-axis. It is also possible to plot a phase with respect to frequency. So here you can see frequency, okay, and is indicated by f0 and phase is indicated by t0. Okay, so this is a frequency and this is the amplitude and this is the phase. Okay, so here time domain display, frequency domain display. So this diagram we show a DC direct current signal with amplitude 10 voltage. The frequency and phase both will be 0. The frequency domain display of the signal is shown like this. Okay, frequency domain 10 voltage display like this, time like this. Okay, then in time domain, then in your frequency domain display like this. Okay, in this conclusion, in this frequency domain, we can show two characteristics of signal. using one vertical line which we can see, and first is the amplitude, right, and the second is the frequency. So vertical line we can see for amplitude and frequency of the signal. We can also show the phase the analog signal base representing frequency domain. So composite signal. Signal and cosine, sine and cosine wave are the basic and purest signals, but they are not useful in data communication. This both cosine and sine is now not used in the data communication. To use the sine wave for data communication, we have to change one or more of its characteristic, such as amplitude in accordance with the data to the transmitted. But then the sine wave does not remain the simple sine wave. Instead it becomes a composite which is made up of many simple sine waves. Thus, when we change amplitude frequency or phase, signal it gets transferred into a composite signal then made up of many frequency. And so here, fundamental just 1 minute. Frequency says spectrum. The frequency domain description of the signal is called frequency domain description of signal. Okay, just frequency domain का जो description है of a signal is called the frequency spectrum. A square wave is made up of fundamental and odd harmonic, third, fifth, seventh, and so on. So composite signal and transmission medium. The data is generally in the form of pulses, and pulse is a composite signal which contains many frequency. Note that P circular shape of pulse is due to the sum of specific frequency at specific amplitude and phase. If there is any changes in the amplitude or phase of this frequency component, then the shape of the pulse will not remain the same. Then medium. The signal always travel over some medium, right, from sender to destination. The medium can be coaxial cable, right, can be the coaxial cable or optical fiber, and so on. The medium does not pass all frequency equally due to its frequency spectrum. Frequency spectrum is a nothing but is a description of the signals. Okay, it may pass some frequency and weaken or block the other frequency. Hence, when composite signal is passed over such transmission medium, at the receiving end, we get the wave having different shape. This we can see in this figure. To avoid the signal distortions, the medium should pass all the frequency present at the input without any changes. But no medium is perfect, and so some signal distribution is bound to take place. Then channel bandwidth, the range of frequency that contain the information is called as a bandwidth. Frequency contain the information. Okay, frequency is the range of frequency that contains the information. Frequency की range of frequency की जो information contain करते हैं, that is called channel bandwidth. But the term channel bandwidth is used to describe the range of frequency required to transmit the desired information. For example, amplitude modulation system needs to channel bandwidth of 100 kHz to transmit a signal of 15 kHz bandwidth. But the signal sideband system need only 5 kHz channel bandwidth to transmit the same signal. All the efforts should be made to reduce the required channel bandwidth to so that we can fit it more number of channels in the same available spectrum bandwidth of the medium, also called as the channel bandwidth, is defined as a maximum frequency it can allow to pass through it without distorting the shape of signal. If the medium has less bandwidth then required, then signal distortion will take place. So here you can see this figure, medium with sending end Then no signal distortion, receiving end is receiving the proper, sending end and receiving end. So some okay, distortion signal matlab distorted signal because it's not properly sent, and this is the same in analog wave. So digital wave, that is, it is no distorted. So digital signal. Okay. So in digital signal, let's see. Okay. Is there or not this figure? Okay, so this is your digital signals. Okay, so the input data which is analog to digital. See here, you can say input data which is analog to digital, and digital signal is a discrete time signal. Okay, it is we already discussed about this, right? It is a discrete type signal, right? So here, see the digital signal in this A0 is represented as 0 voltage, one by same positive voltage. Okay, digital and signals 0 1 0 1. Okay, so here the input data which is either analog or digital can also be represented as what? So this data is represented as a what? Either analog or digital. So when analog and digital is represented as like analog and digital, we have already discussed about analog and digital data and signals, so no need to explain this in detail, because if you understood about the meaning of analog and digital data, then you will get this diagram. Okay, and if you don't understand this now, then go and check first previous lecture, then you will get this diagram. Okay, so this is about your signals here, right? Then here bit rate is there. Yeah, so in bit rate is defined as bit rate. Okay, so bit rate is defined as a number of bits transmitted or sent in 1 second. It is expressed in bit per second. Relation between bit rate and bit interval is like bit rate is equal to 1 divided by bit interval. Bit interval. So, wait interval is the time of corresponding to one signal, 0 or 1. Okay, bit interval is time 0 or 1. So, here time corresponding to 0 or 1 is, hence it is the bit interval or the bit length. 0 and 1, it is a bit interval, length we can say, and bit rate is also called as a signaling rate and defined as the number of bits which can be transmitted in the second, which bits transmit into second, that is a bit rate, and which indicate 0 and 1, that is we can say the length, that is a bit interval. So if the bit duration is bit interval, then bit rate will be 1 upon tp. The formula of bit interval, that is a 1, just 1 minute. Okay, the formula of a bit interval is, that is capital T and base B. Okay, so here, if relation between bit rate and bit interval is like this. So here, if bit duration is bit rate, then bit rate will be 1 upon bit rate will be 1 upon tp. This is the formula of your bit rate. Okay, bit interval. Okay, so this is about the bit rate, and bit rate is also called as signaling rate, and it should be a high possibility. However, will increase in bit rate, the bandwidth of the transmission medium channel must be increased in order to ensure that the signal is received without any distortion. Okay, so this is about your today's lecture's points. So next lecture we will discuss some problem regarding so the some matlab based on the some formulas. Okay, So next if we see bound or bounded, then we will see the one problem. Okay, problem, then bit length, transmission of digital signal, and so on. We will see in my next lecture. So today's lecture over here. Thank you.